Hi everybody, and once again welcome to Pankaj Sir's Echelon Tutorials. In this today's session we are going to start with a new curriculum, that is ISC, and this is for the subject physics, and this is for the 11th grade that I am preparing this video. And the reference book that I am referring to is a book by O.P. Malhotra. Okay, now in this particular chapter, this is the very first chapter, I suppose, right? And in this chapter, we are going to study some basic relationship between the mathematics and physics. Okay. So you know that mathematics and physics both are the pillars, okay, of engineering, and both go hand in glove together, and both are the two sides of the same coin. So if you want to understand physics in totality, you will need to understand the concepts of mathematics. And if you want to understand mathematics, then again you will have to take the support of physics. So it always goes that way. So with that as a starting note, let us start this today's session. And today we are going to study these points that I've already written as a pointer on this screen, you can see. So let us get started. So this is ISC curriculum 11th grade physics, and the book that I'm referring to is OP Malhotra. So let us get started. Okay. Now, while studying higher physics, you invariably need to use and understand the concepts of mathematics. This is very, very important. If you want to understand physics at a higher level, then you should have a sound knowledge of mathematics also. Okay. Now, mathematics and physics both go hand in hand. That is, they always go to support each other. They are two sides of the same coin. Fine. Now, let us start with the simple concepts of mathematics that are used in physics every now and then. So, the very first concept that of mathematics that I'm going to discuss with you people is the quadratic equation, the concept of quadratic equation. So, this use of quadratic equations. Quadratic equations is what? In mathematics, you come across many sort of equations, linear equations, quadratic equations. Okay, so quadratic equation is in a general way, you can write a quadratic equation as this: ax square plus bx plus c equal to 0, such that a is never equal to 0, because if a is equal to 0, then this x square, the first term, will be vanishing, and your equation will get converted to a linear equation. It will no more remain a quadratic equation. So a should not be equal to 0. That is essential. And this ax square plus bx plus c equal to 0 is known as a general form of any quadratic equation, right? And any quadratic equation will have two solutions. I mean, the x variable will have two values, two solutions. These two solutions of this x of this quadratic equation you can get by using this particular formula, that is x is equal to minus b plus minus root of b square minus 4ac whole divided by 2a. This is the formula which is used in mathematics to get the solution to the quadratic equation. You will always get two solutions for the x variable because it's a quadratic equation, right? Now, for example, I have given you this equation: 10x square minus 27x plus 5 equal to 0 is a quadratic equation. Now, let us try to find out the solution of this. So, we'll use this formula: x is equal to, now here if you compare this equation with the general form, you'll come to know that a is 10, and right here a is equal to 10, your b is equal to minus 27, and your c is equal to 5. Okay, using this ABC in this particular formula, okay, you can write x is equal to minus b means minus of minus 27, that is 27, plus minus square root of b square means minus 27 square, minus 4 into a into c, that is 4 into 10 into 5. Okay, whole divided by 2a, that is 2 into 10. Now when you work out this, you will get this: 27 plus or minus root of 729 minus 200 whole divided by 20. And if you work out this, you will get x equal to 5 by 2 or x equal to 1 by 2. So these are the two values of x. These are the two solutions of the quadratic equation, that is x equal to 5 by 2 or x equal to 1 by 2. This is how generally we find out the solution to a quadratic equation. There are many other ways of finding the solution to quadratic equation apart from this particular formula method. Okay, but all that we are not discussing because this is a physics lecture, not a mathematics lecture that we are going to uh, discuss in detail. Okay, so in mathematics we'll discuss all this in detail. So that was the first concept of quadratic equation that is used in physics. Now coming down to the second concept, and the second concept is known as something called binomial theorem. So I've written here use of binomial theorem. This binomial theorem is also many times used in physics. Now what is this binomial theorem? Let us try to understand only the main concepts. Okay. Now binomial theorem. Suppose you have something, an expression like a plus b the whole raised to n, or a minus b whole raised to n. These expressions are known as binomial expansion. Now, why it is known as binomial? Binomial because there are two terms a and b. Okay, and expansion because a plus b or a minus b whole raised to some n. N can be any integer. Okay, or any fraction also. So when it is raised to something, it will be multiplied that many times and you will get a expanded form. So that is why it is known as binomial expansion. For example, suppose I give you an example of this binomial expansion. Suppose a plus b whole raised to 2. This is an example of binomial expansion. So the answer for this will be a square plus 2ab plus b square. Now this is binomial expansion. Okay. Now if you do a minus b the whole square, then it will be a square minus 2ab plus b square. So these are known as binomial expansions. Now many a times we come across in physics where you have to make use of these binomial expansions. Okay, these are just very simple ones. Then you may get complicated ones like 2x plus 3y whole raised to 5, huge ones. Okay, this type of expansions. This is also a binomial expansion. So how to work out the expanded form of this binomial expansion, that you should know and understand. The concept you should know. So in general, this is the formula for any binomial expansion. A plus b whole raised to n is equal to a raised to n into b raised to 0 into c. This particular part, this is known as combination nc0. Okay, this will give you the coefficient of this first term. nc0, nc1, nc2, nc3, etc. ncn. These are nothing but the coefficients. Okay, like here you have minus 2, here you have plus 2, here you have 1, here you have 1. So these are the coefficients of the terms. Okay, so these coefficients you will get from this formula nc0, nc1, nc2, etc. These are the coefficients. This is a raised to n is the first term raised to n multiplied by the second term raised to 0. Then in the second term what happens? The first term, the power is reduced by 1. So here it was a raised to n. Here it will become a raised to n minus 1. Here it will become a raised to n minus 2. Here it will become a raised to n minus 3. That way, the power of the first term goes on reducing until you reach to a raised to 0. And this power of b, the second term, it will start from 0 and it will go on increasing and come up to n. So here you get b raised to 0, b raised to 1, b raised to 2, b raised to 3, and up to b raised to n. Okay. So first term ke powers will go on reducing in each term, and second term ke powers will go on increasing in each term. And this nc0, nc1, nc2, etc. will be the coefficients. This way, in general, you get the expansion of any binomial expression. Suppose it is a minus b whole raised to n, same thing follows. Only here you have to take care is after the first term you will get a negative, then alternately you will have to put positive, negative, positive, negative that way. Okay. Otherwise, all these terms will remain the same. Okay. A raised to n, b raised to 0, nc0. That way. Okay. So these two formulas are very general formulas of binomial expansion. A plus b raised to n, a minus b raised to n. Now here NCR, if you want to find out NC0, NC1, in general NCR, then this is the formula. NCR is given by n factorial upon n minus r factorial into r factorial. Okay, this is r factorial, not r1. right? This is r factorial. So NCR, that is the coefficients, you will get by using this formula. This is the formula that you have to use to get the coefficients. There's another way of getting coefficients which is known as Pascal's pyramid. Okay. Here you have to make a pyramid like this. 1, 1 you have to write here. Then you have to write 1 and 1 over here. And between this 1 you have to write 1 plus 1, 2. Okay. So 1, 2, 1. Then again you have to start with 1. 1 plus 2 is 3. 2 plus 1 is 3 and then 1. And again in the next line, 1 you have to start with. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4 and then 1. That way it will go on. If you want to, if you want me to write one more this thing, you can write this way. 1 and then 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5 and then 1. This is for n equal to 5. So whenever n is equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5. These are the values of the coefficients that you'll have to put. Okay, so when n is equal to 3, the first term ka coefficient is 1, second term ka coefficient is 3, third term ka coefficient is again 3, and the fourth term ka coefficient is 1. Okay, so it works this way. So remember this, there are two ways of deciding the coefficients. Either you use NCR formula, that is combination, or you can use this Pascal's pyramid. Okay. Now coming to next is 1 plus x raised to n. Suppose you want to find out this expansion 1 plus x raised to n, where modulus of x is less than 1. The meaning of this is modulus of x is less than 1 is x is between 1 and minus 1. So whenever this x is between 1 and minus 1 only, then 1 plus x raised to n, where n is an integer, it can be any integer or it can be any fraction also. This particular expansion 1 plus x raised to n is given by this formula. Okay. So here this is not a general binomial expansion. Here instead of a you should have 1 compulsorily, and instead of b you should have x, such that x ka value is always between minus 1 and 1. If such is the situation, then 1 plus x whole raised to n will be given by 1 plus nx plus n into n minus 1 upon 1 into 2x square plus n into n minus 2 into n minus 2 into 1 into 2 into 3 into x cube plus dot 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 this way. So this is another binomial expansion ka formula. Okay. And generally in binomial expansion, terms which are greater than x cube are neglected. Okay. Up to x squared terms are counted. Terms greater than x cube are neglected because the value of these terms, they become very, very less. Okay. So that is the rule. So binomial expansion is also explained. Now let us try to understand what else things are important in physics. There is something called exponential series. Now what is this exponential series? Exponential series is nothing but a series, okay, which will tell you about a particular number, like say E. Now this E is known as Euler's constant. EUILER, Euler's constant. Okay, you have to pronounce it as Euler, and it is written as EUILERS. Now this Euler's constant, its value is around 2.781 dot dot dot. It's an irrational number. Like pi is an irrational number, E is also an irrational number. Now this 2.781 E value is nothing but an expansion of this. Okay, so if you take 1 plus 1 upon n whole raised to n, the limit as n tends to infinity, you will get this expansion 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial. That way it will go on. It's an infinite series. So if you work out this series, you will get 1 plus 1 upon 1 factorial is 1, 1 upon 2 factorial is 1 upon 2, 1 upon 3 factorial is 1 upon 6, 1 upon 4 factorial is 1 upon 24. Now 3 factorial is 3 into 2, 4 factorial is 4 into 3 into 2. It works this way. So 3 factorial is 6, 4 factorial is 6 to the 4 3 are 12 to the 24. 4 factorial is 24. Right? This is the meaning of factorial. Right? So if you do this you will get 2.718. Okay, it's not 781, it's 718. Okay, right? Now e raised to minus 1 is again in the exponential series. You can write it as 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus. So here the minus and plus alternately are going to be placed in the terms. Okay, first minus, then plus, then minus, then plus. If it is e raised to x, the expansion is 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial, and it will go on. If it is e raised to minus x, again it will be 1 minus x upon 1 factorial plus x square upon 2 factorial minus x cube upon 3 factorial plus x raised to 4 upon 4 factorial, and it goes on. Okay, so these are known as something called exponential series. In the same way, you have something called logarithmic series. Now, what is logarithmic series? Suppose you have log of 1 plus x to the base e. Then this log of 1 plus x to the base e can be written in a series form like this. The right hand side you can write this way. So what you have to do is you have to first start with x. So x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4, that way. Okay, so minus plus minus is going to alternately change, and you'll get x, then x square upon 2, then x cube upon 3, x raised to 4 upon 4. This is known as a logarithmic series. For example, suppose you have log of 2 to the base e, then this log of 2 can be written as log of 1 plus 1 to the base e, right? Now this 1 plus 1 is of the form 1 plus x, so this can be written as 1 minus 1 upon 2 plus 1 upon 3 minus 1 upon 4 plus 1 upon 5 minus 1 upon 6, that way. And if you do this total, you will get 0.6931. Okay, and on the calculator, if you type this value log of 2 to the base e, you will get the same answer, 0.6931. Then there's one more logarithmic series, that is log of 1 minus x to the base e. These are the two logarithmic series. So when it is minus, you have to start with minus. You have to multiply the whole thing by minus. So this will become minus x. Then this will become minus x square upon 2. So everywhere there will be minus. Okay, so all the plus you have to convert it into minus. Minus you have to keep as it is. So these are the two logarithmic series. Next is, in physics, you should have a sound knowledge of logarithm. Now logarithm there are certain laws. The first law is log of m plus log of n is equal to log of mn. Second is log of m minus log of n is equal to log of m upon n. Third one is n log of m is equal to log of m raised to n. Fourth one is log of m to the base a is equal to log of m to the base b upon log of a to the base b. This is also known as change of base. If you want to change the base of a logarithm, now say this is log of m to the base a. Suppose I want to change this a to a new base b, then what I'll do is I'll write that log of m to the base b, but I'll divide the whole thing by log of that old base to the base b. So this is how it works. So log of m to the base a is always equal to log of m to the new base b divided by log of old base, that is a, to the base b. And this, if you rearrange, you can write it in this way. This is known as the change of base formula for logarithm. Now, in logarithm, you know there are two types of logarithm. There's something called natural logarithm. There's something called common logarithm. Whenever you have log to the base e, this is known as natural logarithm. And whenever you have log to the base 10, this is known as common logarithm. Okay. So there are two types of logarithm depending on the base. If the base is e, it is natural logarithm. If the base is 10, it is common logarithm. This log to the base e is many a times written as ln x. Okay, suppose this is log x to the base e. Then this log to the base e is written also as ln x. Okay, so log to the base e and log to the base 10. Okay, these two are having some connection. Now what is that connection? Log of m to the base e is always equal to 2.302 times log of m to the base 10. Okay, so log of any variable to the base e is always bigger than log of that same number to the base 10. Okay, and how many times it is bigger? 2.302 times it is bigger. This 2.302 figure you are getting from log of 10 to the base e. Okay, log of 10 to the base e will always be equal to 2.302. So this much logarithm ka knowledge you must have. Okay, now next let us quickly come to use of trigonometry. Now in mathematics, you know, there's a topic, a huge topic called trigonometry. This trigonometry is such a topic which has a wide usage in physics also. So from this trigonometry you should know the certain basic concepts. For example, you should know what is the relationship between the two types of measurements, that is degree measurement and radian measurement, isn't it? Any angle can be measured either in degree or in radian. So there's a relationship between this degree and radian measurement. The relationship is this: pi radian is equal to 180 degree. Okay. So according to this, 1 radian will be equal to 180 upon pi degree. Okay. And this means that 180 upon pi ka value you can always take 3.14. So 180 upon 3.14, if you work out, you get 57.3 degree. So ultimately you come to the conclusion that 57.3 degree is same as 1 radian. Radian is written this way, okay? C on the top of the number, okay? 1 radian. A C, or you can say a half zero. So 57.3 degree is equal to 1 radian. This you should remember well. Or you can say 1 radian is equal to 57.3 degree. And 1 degree is equal to pi upon 180 radian. So you can write this also. 1 degree is always equal to pi upon 180 radian. These are the two basic relationships. Okay. Now, pi radian is equal to 180 degrees. So 90 degree will be how much radian? So if you do cross multiplication, you will get 90 into pi divided by 180. So 90 into pi upon 180 is pi by 2. So 90 degree is equivalent to pi by 2 radian. So that I have written here. 90 degree is equal to pi by 2 radian. In the same way, 30 degree is equal to pi by 6 radian. 60 degree is equal to pi by 3 radian. 90 degree is pi by 2 radian. I have already discussed here. 180 degree is pi radian, I have already discussed here, and 270 degree is 2 pi by 3 radian, and one more if you want, then 360 degree is equal to 2 pi radian. Okay, so this is about the relationship between the degree and the radian. If you want to convert any angle from degree to radian or from radian to degree, you can make use of this concept. Okay. Next is, let us try to understand the values of the trigonometric ratios. Okay, now there are some 6 trigonometric ratios. You know there's something called sine of theta, cos of theta, tan of theta. These three are the basic. And the reciprocals of this, sine theta ka reciprocal is something called cosecant theta, cos ka reciprocal is secant theta, and tan ka reciprocal is tan theta. So these are the 6 trigonometric ratios. Okay. So in trigonometry, you have 6 ratios, and these ratios, sine theta, cos theta, and tan theta, of certain basic angles like 0, 30, 45, 60, and 90 degree, the table has been given over here. Okay. So you have to somewhere remember the trick to remember this table. Okay. So sine of 0 degree is 0, sine of 30 degree is half, sine of 45 degree is 1 by root 2, sine of 60 degree is root 3 by 2, and sine of 90 degree is 1. Same way, cos of 0 degree is 1, cos of 30 degree is root 3 by 2, cos of 45 degree is 1 by root 2, cos of 60 degree is 1 by 2, and cos of 90 degree is 0. Coming to tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1, tan 60 is root 3, and tan 90 is infinity. So these are the trigonometric ratios sine, cos, and tan of the angles 0, 30, 45, 60, and 90. There is a way of remembering this particular table, but that I will discuss when we are dealing with the subject mathematics. Okay. So this is something which is very handy when you are doing your physics. Apart from this, in trigonometry, you have these things that you should also be very much familiar with, like sine of a negative angle. Sine of minus theta is minus sine theta. Cos of minus theta is cos theta. Tan of minus theta is minus tan theta. Okay. Now these all things, you should have very much on your fingertips. These are the concepts of trigonometry which are going to be used in physics. Okay, somewhere or other you will come across, and there if you fumble with this concept, or if you are not uh, thorough about these concepts, then you will always find your physics difficult at that particular stage. So these are the mathematical concepts which you should become very much familiar with. Okay. Next is sine of 90 minus theta is what? Cos of 90 minus theta is what? Tan of 90 minus theta is what? So these are the things I have written here. Now here I have written certain things for you to remember, but then it is not easy for you to understand unless and until you do these concepts of trigonometry separately in mathematics. You won't understand. I have just listed out these formulas that you should be aware of when you are dealing with physics. Okay, but to understand how it works, you'll have to go into mathematics and do a little work, a little homework over there, and then only you'll be able to understand these things. So if you're not aware of these mathematical concepts of trigonometry, don't rush to do physics. Okay, because physics may you will come across these concepts, right? Similarly, you have this concept. Now, these concepts, in short, are known as allied angles. Okay. So, in mathematics, for ISC, in mathematics, you have a book called O.P. Malhotra. Okay. I'm so sorry. In the starting of this, I have mentioned that I'm referring to this book, O.P. Malhotra. No, I was wrong. O.P. Malhotra is the book for the mathematics. Okay, this is the physics. For physics, I'm using a book which is known as Kumar and Mittal. Okay, so sorry. Because this particular chapter is dealing with the mathematics, uses of mathematics in physics. I wrote the reference book of mathematics only, the author of the reference book of mathematics. So the reference book for the physics is Kumar and Mittal. Okay. I refer to this book. Okay, so this is from the Kumar and Mittal book that you will find all these things, right? Okay, so for ISC, for mathematics, if you want to refer to any good book, then it is this O.P. Malhotra. In this O.P. Malhotra book, okay, you will find in the trigonometry unit, or in the trigonometry section, you will find all these things given there. Okay, from there you can always become familiar with these concepts, because these are the concepts which any day, anytime will pop up in the study of your physics. Is that clear? So trigonometry is something which you should know thoroughly. These are other concepts in trigonometry. And now these concepts, I will be dealing with them more in detail when I teach, when I prepare videos on mathematics. Okay. So now I will skip all this, and I'll come to the another concept which is known as okay, these are the formulas, important formulas that you should know in trigonometry. There's something called addition and subtraction formula. In that you have this 1, 2, 3, and 4 formulas. Okay, this 4 formula in totality is known as addition and subtraction formula. Then you have something called multiple and sub-multiple formulas. Now these are the 1, 2, 3, 4. 4 formulas are on multiple and sub-multiple formulas. This also you should be very familiar with. Then you have in trigonometry something called product formulas. So in that also you have these 4 formulas. Okay, and many a times they call it as factorization formula and defactorization formula also in mathematics. And that is why I'm saying you, when you if you are, whenever I prepare my maths ka video, you will be able to understand all these concepts, right? So these are totally known as product formula, and these 4 are known as sum and difference formula. Okay, as I told you, these are also known as factorization formula, and these are known as defactorization formula, just another name. Okay, so these formulas also you should know how to use them, how to by these formulas. All this you will be doing in mathematics. Now last, you will have to apply concept of limits also. So some important limit formula. Now, whenever you want to find out the limit as theta tends to 0 of sine theta, the answer will be equal to theta. So this is what you should know. Okay, limit of sine theta as theta tends to 0 is always equal to theta. Same way, limit as theta tends to 0 of cos theta is always equal to 1. Then third one is limit as theta tends to 0 of tan theta is equal to theta. Because this is also theta, this is also theta, you can say that limit of tan theta as theta tends to 0 is equal to limit of sine theta as theta tends to 0. Okay. Then this is one more important formula in limits. Limit as theta tends to 0 sine theta upon theta is equal to 1. Now these are the formulas of limits. Okay, limits is a concept in mathematics. This also we will be discussing in detail when we deal with that subject mathematics. Okay. Apart from this limit, one more thing that is important is limit of delta y upon delta x as delta x tends to 0 is something which is known as dy by dx. This dy by dx is something which is known as derivative. So derivative is derivative, or you can say differentiation. Derivative or differentiation is a mathematical concept which is erupting from the limits ka concept. So whenever you are finding the limit of a ratio like dy delta y upon this, delta y upon this is read as delta y upon delta x. Okay. So delta y is the change in y variable, delta x is the change in x variable. When you find the ratio of this and when you take the limit of this ratio such that delta x is tending to 0, then whatever answer you get, that will be dy by dx. That is known as the derivative. So this derivative is a concept which also you will have to understand in mathematics so that you can understand your physics. Okay. So this dy by dx is nothing but derivative of the function y with respect to x. Okay, dy by dx is what? It is the derivative of the function y with respect to x. Now this dy by dx is the same as tan theta. Now what is this theta? You know, theta is the angle of inclination. Now if you have a line, okay, and with the x-axis, suppose this is the x-axis, with the x-axis suppose the inclination is 30 degree, then this 30 degree you have to take as theta, and tan of this 30 degree is nothing but the slope of this line, n. Okay, tan theta means tan of 30, tan of 30 means 1 by root 3. The slope of this line is 1 by root 3. Now this tan theta gives you the slope, and dy by dx also gives you the slope. Okay, so this tan theta will give you the slope if you have the knowledge of this angle of inclination theta. And suppose if you don't have the knowledge of this angle of inclination, but if you know that this particular graph has a it is a y is equal to f of x function, if you know the function, okay, then this function ka you can find out derivative dy by dx. That dy by dx will give you the slope of this line. Okay, so these are the concepts that you are going to use in physics. These are the concepts of mathematics. Now quickly let us do some of the derivatives of some simple functions. So suppose y is equal to f of x may, suppose y is a function like x raised to n, then the derivative, that is dy by dx, will be n x raised to n minus 1. Suppose the function is a constant function, y is equal to k, then the derivative of any constant function is 0. Then suppose the function is y is equal to a raised to x, then dy by dx will be a raised to x into log of a. Suppose the function is y is equal to e raised to x, then dy by dx will be e raised to x only. Suppose the function is log x, dy by dx will be 1 by x. Suppose the function is sin x, derivative will be cos x. Cos x ka derivative will be minus sin x. Tan x ka derivative will be secant square x. Y is equal to x ka derivative will be 1. Suppose you have a function y of the form of u plus v, where u and v are both functions again. So if you have a sum or difference of two functions, then the derivative of that particular function can be found out by adding or subtracting the individual derivative of each function. So dy by dx will be equal to du by dx plus dv by dx. Okay, or dy by dx will be equal to du by dx minus dy by dx if it is u minus v. Same way it is if y is equal to u into v, where u and v are again functions, then this is the formula: v into du by dx or u into dv by dx plus v into du by dx. U upon v, dy by dx will be v into du by dx minus u into dv by dx whole upon v square. So these are the formulas which are going to help you in finding the derivatives of certain functions. Now in physics, we have, suppose s is a displacement, then ds upon dt is nothing but derivative of s with respect to t. This ds upon dt quantity is known as velocity. Okay, so see here we are using the derivative to find the velocity. So velocity is nothing but derivative of displacement with respect to time. Same way acceleration is what? It is the derivative of velocity with respect to time. Okay, so derivative concept can be used to find out the velocity and acceleration in physics, right? And same way acceleration is equal to dv upon dt can be written as dv upon ds into ds upon dt, and dv upon ds is nothing but v, so acceleration is equal to v into dv by ds. Now if dy by dx or tan theta is equal to 0, what it indicates? When dy by dx is equal to 0 or tan theta is equal to 0, that indicates that the slope of the line is 0. And when the slope of the line is 0, that means the line is either horizontal or it is parallel to the x-axis. Okay, so these are the meaning of derivative concepts how we are using in physics. Suppose dy by dx is greater than 0, that means the slope of that graph is positive, and that means that when one quantity is increasing, the second is also increasing, or when one quantity is decreasing, the second is also decreasing. When the slope dy by dx is less than 0, we say that the slope is negative. The meaning of this is when y increases, x decreases, or when y decreases, x increases. When dy by dx is equal to 0, that means that the slope is 0. This means that the constant, this y and x are independent of each other. Okay, so they are not dependent of each other. Now, many a times in physics, you will come across this s is equal to f of t, v is equal to f of t. We say that this s means displacement. Displacement is a function of time. Velocity is a function of time. You may get a formula in this type. Okay, so this is how derivative is used in physics as well. In the next session, we are going to study about the usage of integration in physics, and then later on we'll see how vectors and scalars ka concept, the addition and subtraction of vectors, etc. is used in physics. So this is the starting lecture of this 11th grade physics, either for ISC or you can say for IBDP or you can say for HSC, whatever. But this, or you can say for NEET exam preparation, this is the starting stuff that you should start with. Okay, so slowly and steadily I'm going to go ahead stepwise and topic wise into this particular topics. So that was all for today's lecture, and I'm going to wind up this video here and here itself. See you in the next video perhaps, and till then, goodbye, take care all of you.